Yeah, welcome to Java E-Talk. The deal this time, I thought I've just 45 minutes, and last year there was a lot of overlap between my session and the workshop. So the idea is I will try to explain you what to do to implement in productive way Java E applications with slides, and in the workshop will be just code. I think this is a good deal. So we'll just hack everything without any slides in the workshop, and now I would just like to explain you with slides how to be efficient. Yeah, this is the idea. Usually I hate slides, so it was the very first time I created so many. So I'm working with Java since 1995, and I still like it. So this is actually the interesting part. I'm not searching for new adventures. I'm just perfectly happy with Java programming language, and I think I'm also productive with Java, and particularly Java E. And in most of my projects, what I see is they don't have the problem with the language, rather than with, I would say, crazy architects, right? So the developers are, I think, no project died because we have to write getters and setters, right? So, for instance, or because, I don't know, we don't have dynamic features. But I saw lots of projects fail because they had to implement 15 layers to make a button visible on the view, right? And you can make so project fail regardless of the language. I think if they will introduce Ruby or PHP or whatever and get the crazy idea to build it with 500 patterns and 20 layers, it will fail as well. So this is actually the problem I see in projects. Is like everyone is complaining Java is not productive, and at the end it's not the problem of Java, rather than crazy patterns and cargo cult or whatever. So at least I never was in project in Poland. But I was a lot of projects in Germany, Swiss, Austria, and in Europe, but in Poland, no Poland so far. So this is my experience. So probably in your case, it's a little bit more efficient. In my case, this is crazy. So and this will be the talk about. And if you don't believe me, I will try to show you in a workshop how efficient Java E architecture code and architecture could look like. Okay? So yeah, I'm working with Java. I spend 90% of my time in projects, and from time to time I'm organize a workshop at Munich Airport called Air Hacks. If you like, the next is in July, and I got already some Polish guys from Ireland, actually. This was interesting. They came from Ireland, but were Polish. So, so 2 books. I don't brought the books, but I brought the T-shirts. T-shirts are heavier than books, so if you ask questions, you get a T-shirt. But I cannot show you the book. This is also a deal. So this is the otherwise. So J2E is not Java E. This is the what I see in projects. Like everyone complained how complex J2E is because they have to write lots of XML and DTOs and DAOs and everything else. So J2E is history since 2006, right? So and the strange part is since 2006 we can build lean applications. But no one does that. It means they build the old crap from, I don't know, 1945, right? So like 50 layers and patterns and indirections and lots of XML, and don't repeat yourself is actually always repeat myself. It's like the new pattern in enterprise. It's like interface, implementation, and write an XML that both belong together, because at some point in time, someone came to the idea that one implementation could be changed or something like this. It's just crazy, crazy stuff, right? You cannot believe how much code I actually deleting in my project. It's incredible. And after the end, everyone is, okay, this is nice, but we didn't know that you can implement that way. This is like a Java disease or enterprise Java disease, to build lots of stuff without any meaning and then complaining this is not maintainable. So what cargo cult is actually meaning is really interesting. I really like that. You know what cargo cult programming is, or cargo cult? I explain always if I have the chance to do that. So cargo cult is, you have to look up in Wikipedia. It's like there was some Pacific island, and in the Second War there were the natives on the islands never saw civilization before. And the U.S. Air Force came and landed and built some rollways, and they came with airplanes, with military airplanes. And the natives just observed the situation. They say, okay, everything is logical, right? First you have to build a tower. Then we need someone with 2 coconuts on earphones, of course, 2 coconuts. make some noise and lots of light, so they need fire, and then a nice birds will land and bring up cool stuff like chocolate and all that. They didn't saw any relation between the Second War and the arrival of US military on the island. This is like, in my project, it's like, we are building here an interface, then we create an impl class, which we cannot name anymore because it's impl, and then we write some XML, because in 5 years, probably, we will have to change this part, and it will be really efficient in five years. So we invest right now 1 hour to write hello world, right? So this is just crazy. So it's like, this is absolutely cargo cult. And the interesting part, at J2E Day, there was required to do something like this, because there was a lots of dependency on the platform, on API. In Java 6 and Java 5, even in Java 7, there's actually no dependency on the platform, so you can be really, really efficient. But no one does that. This is the crazy part. In my current project right now, they started with a framework, but they forgot about the business logic, right? So you should start with business logic, and if you need a framework, just take it. This is like crazy stuff. So everything I'm saying here is obvious, but no one does that. This is actually, at least not in Germany, Austria, and Switzerland. Probably you are smarter than we, but it's just crazy, right? So first, there is a difference what we are doing. So what I see in my project, there is a big difference whether you are developing a product or a project. What's the difference? If you are building a product, it's a little bit harder because you need some abstractions up front. Because it is very likely that you will get multiple databases to deal with. Or, I don't know, several authentication systems or something like this. In projects, there is nothing like this. So in projects, you get one database, and the strange part is, or the given part is, the database often outlives the apps. It means the database in a company lives longer than the apps. So actually, decoupling for the database is crazy, right? Why you would decouple from something which lives longer than you, right? So other ways around would be interesting. Also, you usually in projects, you get some kind of business experts or product owner or business department, and they told you what to do, and you can ask them to get a sense whether something will vary or not, right? So in one project, there was a crazy complex algorithm, and I asked them, should we make it replaceable? And the answer was, you are crazy. We spend lots of money for the thesis to implement the algorithm. There will be no other algorithm in the next few years. So for me, it was a clear answer, building an interface to encapsulate or strategy pattern to encapsulate the algorithm is counterproductive. It would be even unmindable, because why? Because if someone would see my crazy framework encapsulating an algorithm which never changes, it will imply it will change. It is harder to understand, right? So what we did, we didn't decouple from the algorithm because the likelihood was very, very low. So what we should do in our projects before we do something, think about the probability. How probable is something? If something is not probable, I do nothing to decouple from this. It's just write straight code. If something is very likely, do it. For instance, how likely it is that you will replace the logging framework in running applications, something like this. Very, very unlikely, right? Okay, if you have any questions, ask. The more aggressive the question is, the higher is the chance to get a t-shirt. Okay, so if you say, stupid, no, we have exactly problem because we didn't wrote on one impl, then you get a t-shirt probably, something like this, right? So, don't start the project with talking and meetings. So it's just crazy. It's like, I think many believe that talking is cheaper than writing code. It's like we're starting projects with talking and meetings and specifying, and we're burning lots of money without any outcome. So what I would like to do is to just start from day one with coding. And if it doesn't work, throw it away and code another time. It is, you will spend exactly the same money as you would spend by talking, except you gained on experience. And this is, in one project, it was absolutely forbidden to me to implement something because the architect told me, if you write something, it will be defect. So they will be used and there is over. And what they did, they talked 1 year how to implement something, and then was no more time for the actual implementation, so we could do whatever we wanted. So after the 1 year, the whole discussion was over, and we built complete different system. So it was actually crazy. And the problem is I cannot do nothing about against that. In every project is the same story. Like at the beginning is lots of time, and everyone talks about patents who doesn't even matter, you know, factory or not, who cares about that, right? And there is no more time for the actual implementation and testing, and then you can do whatever you want, or we just fix errors. And I don't know how, but usually I try, you know, to address in Scrum is also the problem. So you get at the beginning, you know, user stories which doesn't matter. I mean, you know, and then at the end they become more. So it's always the same problem, regardless of the process. So instead of, I would say the following: time boxing, half-an-hour meeting. If something is longer, it should be forbidden. Yeah. I saw somewhere a nice suggestion. You should drink a lot before the meeting, so it will not take longer because you have to do to the toilet, you know, to the restroom. So this is a good strategy, or do something more chemical or whatever, but reduce the length of the meetings, right? And if something is unclear, build a prototype or proof of concept or spike, whatever, however you call that. Java 6 is lean enough that you can do whatever you want in 2 hours. So we can do it in workshops. So ask me something, we can hack something, or show you the code. It's really, really lean. And instead of talking, implement it. Iterate, and learn from code, not from meetings. This is actually the first time. And fail fast, it sometimes says like, just an example. So stateless versus stateful. So the architect stateful won't scale, and stateless is harder to implement, so what to do? Instead of implementing a stress test to say, okay, we can handle so many sessions. They're talking about 3 days, and no one knows actually how much traffic an application server can handle. And the truth is, it's an incredible amount of sessions. It's actually so incredible that I recorded a screencast. You can go to adam-bean.tv, I think. It's like with standard Gladfish, 500 megs of RAM, you can create 120K sessions, 120,000 sessions. What I do right now, at the beginning, I ask the architect how many sessions we can handle with a server. I got answers like 200. So okay, this is a failed, you know. Because 120K and 200 is a huge difference. And in most projects, we have even cluster. So we could handle with 4 clusters 500,000 sessions. And in the companies, sometimes, there are smaller companies that don't even have so many employees as we can handle the sessions. And they are still concerned about the scalability. Just a basic fact. And just the scalability, we talk a lot about that. I think I have to convince 5 days just talking what's the difference stateless versus stateful and all the stuff. So fail fast, it means implement something, if it doesn't work, throw it away, implement something else, but don't talk about this. So this would be, and in some companies, meetings are even forbidden. I would don't go that far, but meet somewhere else, you know, in Starbucks and drink some coffee or something. So no interfaces. So so in Java 6, I don't have any interfaces, nothing. Interfaces are suspicious. So in my case, what it means is, if you don't see any interface, it means in my case, nothing will vary, very likely. If you see an interface in Java 6, in one of my projects, you can check the open source project, what I contributed or whatever, it usually means strategy pattern. It means something varies. This is high-level API, whatever. And by the way, interfaces are actually a very bad idea to implement APIs, because abstract classes are widely more robust than interfaces are, but no one uses abstract classes for some reason. Everyone uses interfaces. And the strange part with interface is, if you create interface for everything, you cannot name the implementation properly. And this is what I see in projects: interface, order service, implementation, order service, impl. And now the question is, there's like design for extension or whatever, yeah? But there is no more extension because you cannot name the second implementation properly. Yeah? You could name it order impl 2, second, or whatever, but I mean, game over, right? And in some projects, they even write an XML file and say, okay, this is the relation between the interface and the implementation. So the dry was violated 3 times. And then they're complaining Java is crap because it's not productive. It's like, okay, there is in no Java specification written that to implement one method, you have to create 2 files, one called impl, and manifest everything in XML, right? I never saw in Ruby, PHP, or other projects dealing that way. This is actually what why they don't need such strange patterns, right? So this is actually an interesting story. So no interfaces, which means all interfaces are forbidden. And what we actually did in migration projects, we deleted all interfaces. And the crazy story is, it mostly works. So what it means, the interfaces were superfluous before as well, because there was no case with 2 implementations for an interface. What's the original idea of an interface actually is. Okay? And sometimes I hear we need interfaces for mocking. It's no more true for 8 years or something. Yeah, it was through a JDK 1.0 probably, but in JDK 1.0 there was not even interface, I think. They came in JDK 1.1, so who cares? So, no external libraries. So, if I start, I'm talking about Java 6. Just about Java 6. If you have an application server which is Java 6 capable, JBoss 7, Glassfish v3, Tommy, great application server, WebLogic 12c, or WebSphere, the Noesis 8, or even Liberty. So if you have these application servers, what it actually means, you have all the libraries you need on the application server. So what you should do, you should start to leveraging them instead of deploying them another time. And actually, an amazing amount of business logic can be implemented without any library. Except probably if you, need, of course, need prime faces or something, you can do it, or rich face or whatever. So why is it so important to me, no external libraries? There are actually multiple reasons. The first reason, which I care a lot, is build performance. Build should be fast. The smaller the war, the faster the build. In one project, they used Tomcat, and the war was 500 megs big. Deployment took 40 minutes. And the architects told me they have lightweight architecture. It's like, what is lightweight? Yeah? You are not lightweight, and your Tomcat is probably lightweight, but the war is not lightweight at all. So from my perspective is, what should happen is, the application server can be thicker, but my war should be as small as only possible. The first reason is build performance. If you would like to be productive, you should dedicate one person in a project to improve the performance of Jenkins. At least in my project, it's like the Jenkins, we get the worst possible machine. It's like we got virtualized server with C64 behind that, which builds an hello world in 3 hours. It's just crazy. If you would like to save money, buy a machine for few K, it should be really, really fast. The faster the feedback, the more productive you get. But what you can always do is to reduce the size of your war. So part one is productivity. Part two is maintenance. So in some of my projects, I'm involved in so-called task forces. So we find some problems, or my customer finds some problems, but cannot solve them. Some of the problems are implemented in the external libraries. So, and the problem is, they are no more maintained. So in one project, the external library was so old that we didn't even find the source code for that. So I searched for archives.org, I searched for Apache, it was gone. So in my opinion, if you have enterprise, longer living project, what you should do is any external library should be checked out with source code, make it buildable inside, and this is your ultimate insurance for external library. Just downloading something with a jar, it will disappear in 5 years, I guarantee you. So, and this is actually nice for me because a lot of contracts to fix such a stuff, but it's just crazy to doing something like this in enterprise, right? So if you would have to external libraries, I would do the following. A spreadsheet, say, okay, I would like to have this library because I can save so much time. So, and then just say yes or no, and we decide together. And if the library is there, search for the source code, make it buildable, and this is your insurance. Or you should always upgrade, but never does that, because we have own release cycle. Okay? You got a point? And the more external libraries you get, the more complex your project get, and you will find less and less developers who know all the dependencies. So in one project, they use Tapestry for UI. And I actually this was actually interesting projects. And after a workshop, they say, okay, they want to switch to JSF or whatever. It's like, why? It is nice. The problem is we don't find any developers with Tapestry skills, but we find many developers with Java E skills. This was the only problem. After the project is working right now. And the more esoteric your library gets, that's the worse it becomes in maintenance phase. Right? Okay. No external libraries. I'm absolutely serious about that. It means in my projects we have nothing, and we can, in my workshop, ask me, show you my open source project. I wouldn't like to show you my commercial project because of NDAs, but it's very like the same. Of course, if you need encryption or something, you have to use bouncing castle or whatever. Don't re-implement that, but don't start downloading all the commons from Apache and Guava, whatever. Everything is cool, but it increases the size of the war and complexity of your project. Okay? Pardon? So how to use the Guava? How to use? Yeah, if you really need it. If you have a functional algorithm project, just use Guava. In my project, we don't have to use that. It's just trade-off. Everything is trade-off.
It's better to, for example, deploy the Guava into the application server
No, I would always deploy it with the war. But the other story is, I forgot the slide, but the other story is the deployment. Just forgot to mention that. In my project, it looks like we have, for instance, most of it's Glassfish or JBoss, with very, very similar deployment. You have one base deployment is Glassfish, and we have one domain per application. There is never multiple wars per domain. And this works perfectly. And shared server, it's crazy. If you think about this, you gain 30 megs of RAM, and you lose lots of flexibility, maintainability, monitoring capabilities, and whatever. And I would even go a step further. What I'm doing with my server where I'm block running right now, I'm installing KVM, and there will be one operating system per server, per application. And this becomes really great. Why? KVMs are very efficient. They can cache common stuff, so there is not a lot of overhead. And I can monitor per bandwidth, CPU usage, per application and OS. This is great. And I mean, I bought 24 gigabyte of RAM for 180 euro. Was the fastest available RAM at Amazon.com. So, of course, I could save 20 euro and don't do that, but why? Okay? The whole machine, I will publish all these specs on my blog, is a Xeon 8-way, 124 gigabyte of RAM, 24/7 Barracuda hard disks, and super micro motherboard, and very, very efficient power supply. It was most expensive part, and the whole machine does cost 1,500 euros. 1,500. And the most expensive part was the chassis. It was designed by BMW USA. So it looks nice. It was not, but I mean, it's crazy. Without any rebate, nothing. It's just stock machine. I built it by myself. And I can run 8 parallel operating systems right now, and there's nothing to do. And they perform, and my machine outperforms the machines from my customers, because I don't know what they are doing, but probably save 50 euros or something, right? So no XML. In Java 6, there's no XML. So what I do in my code reviews, really, I have a grep. I'm grepping for XML. If I find an XML file, I look at that, why is there? And usually it's not necessary. So it's perfectly fine for you to start on Java 6 project without any XML. Any XML means you will need persistence XML with 5 lines of code, and you will need a beans XML with 1 tag. I mean, forget that. But there will be no EJB jars or whatever. All the stuff is to come. What I see in Java 6, the developers are starting Java 6 projects with EJB jar, application XML, and all the old crap is optional. You can do that if you like XML, but you don't have to. Okay? I have the impression some companies invested already a lot in the editors, XML, and all infrastructures that try to use it a lot, right? But this is not necessary in Java EE space.
Okay, how do you define some developers' environments? Some developers work on the same project. How do you parameterize?
If you have Maven, the obvious choice would be profile. So Maven, you need a little bit XML. Maven. Yeah, okay. I mean, Maven, but Maven is outside Java EE. You can use Gradle or whatever. But I mean, Gradle would be not XML, could be, but it would be profile. Will you attend the workshop? I will code it for you without XML. Agreed? Okay. So this is your first question, and you get the T-shirt in the workshop. So so we have more T-shirt here. The question, if you don't attend this workshop and someone else will attend, the question is how to configure application developer-specific or stage-specific without XML. Okay, this would be one nice use case to implement. Okay, other questions?
I have one question about the external libraries.
Yeah.
So if you build your web application with Maven, for example, you can mark the libraries that provided.
Yes.
And keep it on the server side, so your war file is too small.
Yes. So I have one API in Java 6. I will show in workshop as well as Java 6 API. This is provided. Or if I use Archelion, it is embedded Glassfish or embedded JBoss. This is provided, and the war is basically empty, really empty. It's like.
Then you are allowed to use external libraries?
Pardon?
Then you are allowed to use external libraries?
Oh, what I meant. Okay, this is external libraries. It means libraries in war. You should rename the slide. What I didn't meant is Java EE is external library. I meant you need Java EE to implement Java EE. So you need the API, but I don't have, how to call that, non-Java EE libraries or something, right? So usually what I have is for the following. Java EE API provided. JUnit is test. Mockito, great framework developed even by a Polish guy, I think, is this test as well. Archillion, but this is always, nothing lands in war. The war is empty. This is what I meant. Sorry for that. So war contains just classes. There are no jars in war in the first iteration. We are very, very specific. In once we used a library which is able to parse a mathematical expression. So okay, so of course we never implement that. But I'm very suspicious, common and all, you know, the nice stuff, or there is, I forgot the library, Lombok or something like this. Okay, it's nice stuff, but why? T-shirt, right? You have more T-shirts in the back, so, and I have to give them away because it's crazy heavy. So next time I will bring the books. So, most common question, crazy, where to find all the annotations? And this is not the deal to search for an annotation and apply them in Java EE. This is the most common. Actually, everything starts with an EJB. Why? Because we need transactions. Without an EJB, it gets too complicated. And then you can inject all the POJOs, interfaces, whatever you have with add inject. Nothing else, add inject. If you need some persistence, there is an add entity, and everything else is optional. So this is not like, this very, very common questions workshop, okay, there are 50 annotations, how to find them and what they mean. So, okay, usual, in my projects, if a class ends with 5 annotations, it means someone likes really annotations, right? There is one exception from the rule. If you have an entity with some custom mappings, you could expose the entity as XML or JSON as well. So you will probably have the entity and JAX-B annotations as well. This is a lot better than introducing a DTO. But you know, this is not like in Java 6 we are searching for annotations and what they can do and then apply them. I would start with the basics, and these are the basics. And if you have a problem, then search for an annotation. This is my approach, and it works extremely well. Extremely well means in one project we had students without any Java EE experience, but with Java experience, and they got it. So in the end, they didn't even knew what EJB is or managed bean. It just worked, right? Synergies. So in Germany we have conferences as well. Actually, Poland is a Java land. I wrote in my blog, it's absolutely so. This is actually, we have InfoShare here, and at the same time there is a GeekOn somewhere else, and I was invited here first, and then to GeekOn. I came here because of the weather, right? So no, I was first here, and I have to work. I cannot travel back and forth. But it's actually interesting. 2 huge conferences. We don't have such thing in Germany, but we have also large conferences like JAX. Now, this conference, very popular topic is like just build everything with CDI. You can do it. It's context independence injection. So you can do whatever you want with CDI. You can implement your own extensions, your own transactions, everything. You can even implement your own application server with CDI, like, for instance, Recent does this, Coucho. This CanDI, they build the application server partially with CDI. The question is why? So it's like a sports is okay, but in a commercial project, why I should pick just one library and implement everything with one library if I have everything in place? So what I try to do is to use everything, what's on application server, as much as possible, because otherwise I would go with Tomcat and not with Java 6. So we have actually 2 strategies, Tomcat with Spring or Java 6 without nothing. The mix is crazy, right? So this is, and at the beginning you have to decide. So there's actually 2 strategies we can go either way. And in Java 6, what I do, EJB for transactions, asynchronous processing, and CDI for everything else. So in the front, I have EJBs, and everything is CDI. I don't even try to avoid EJBs. From the performance-wise, EJBs even in some cases a little bit faster than CDI. That's actually the crazy stuff as well. So the overhead in EJB and CDI is negligible. I never saw a project with problems with EJBs. Lots of projects with problem with transactions, locking, but never with EJBs. And what I often hear, now the performance improved is absolutely not true at all. The performance or the overhead is got worse because at the beginning of J2E, the code was generated at deployment time. If you look at WL no delete in WebLogic or JBoss, they had to generate all the code because dynamic proxy was not there. And what now happens in Java 6 inside, there is bytecode manipulation or dynamic proxies. And reflection is always a little bit slower than generated code, right? But either way, I think I tried to measure the overhead between a POJO and EJB, and it was like 1 millisecond or something. It's just documented everything in my blog, and even recorded some screencasts. So you watch it live because because no one believes me. Okay, there is this documentation. You can do it, rerun it on your machine if you like, right? So Design patterns. These are the origin J2E patterns, and 90% of the patterns are absolutely dead. So, and I still see them in projects. So the first part is only interesting if you would like to implement your own web framework. Right now, I think times are over of implementing a web framework. Now everyone would like to implement own language, right? A programming language. This is the new wave. But frameworks, no one attempts that. This is as Java started, there was on every conference there were 5 new web frameworks. Right now is Java not efficient? 5 new programming languages running on VM. And in 5 years we get something else. This is normal. So. Forget about this. The basic idea here, we need something like a front controller. It's usually a servlet, and it gets all the traffic, and it dispatches the traffic to something else. And all the modern frameworks are built like that, except Play. It's not servlet-based, but all other web frameworks are like that. So this is a little bit more interesting. So data access object, start with that. This is absolutely dead. So if you even attempt to build a DAO, what you will see, you will build a POJO, which is very, very similar to the entity manager without any added value. Yeah, a flow heater is nothing. It's just like, I don't know, you're decorating something without knowing why, right? And you've asked the question why you're doing that? Yeah, and someday JPA could disappear. Okay, when? Yeah, 20 years or when? So, and there's also a problem. It's called leaky abstractions. What leaky abstractions means is if you even, encapsulate fully the JPA entity manager, if we switch to flat files will behave differently than JPA, or NoSQL will implement differently, will behave differently to relational database. Transfer object is actually gone, is no more needed because we can detach entities. So in my projects, I don't know, this could be even German disease, I would say. It's like we have entities and data transfer objects, and they are identical. So, and they put a text field in the view, and the entity gets always maintained with the DTO. They remain for the life cycle of the project identical. If I ask the question to the architect, why are you doing that? Of course, because of decoupling. It's like, look, go to Subversion. You search for the history, the last 10 years, right? They were always identical. So there's no decoupling. This is what you are doing. You are the compiler, right? So, or code generator. So, and what I see, if frameworks like Dozer are working well, your architecture is suspicious. Because what Dozer is capable to do is to copy very efficiently objects back and forth. So if you have to configure Dozer, it's a good sign. It means that data transfer objects look differently to entities. What it actually means, there is an added value in DTOs. So in my projects, we can use DTOs only when they look differently to entities. Identical are forbidden. You mean, don't repeat yourself. All the common sense patterns are talking against that. So domain store pattern is the DAO 2.0. If you look at the domain store pattern, it looks very the same like the entity manager does. It is actually the entity manager from JPA implements domain store pattern. Composite entity is just crazy, don't need it anymore. It was like relations in CMP 2.0. Business object, this was the great idea in 2002. Persistence can be object-oriented. So the strange part is JPA entities can be object-oriented, and in some projects, architects forbid behavior in the entities. And what happens then? We have no more objects, right? You have asked the question, why not? No answer. Like, not allowed. So, okay, but why? Not allowed, yeah? So if there is no reasonable answer, it means it is probably not maintainable. So in my project, it's absolutely allowed to have behavior in the entities. Session facade is no more needed because what it did is it decoupled from CMP 2.0. The only pattern which is actually interesting is application service. We name it boundaries, like the entry point to the business logic. A dedicated, perimeter level interface to the business logic. And it means behind the boundary, or even the boundary, do not know nothing about the UI. The boundary should not know nothing about RESTful web services, JSF, UI, or whatever. Service locator is dead because we have dependency injection. Business delegate is dead because it looks identical to session beans. And yeah, we killed everything. Service activator was the idea, it was the way to implement asynchronous services And with JMS, we don't need it because we have a single annotation called asynchronous. So I mean, I would never call that pattern. So I mean, we killed everything right now, except application service. So and what really happens? Java 6 project starting with the patterns. So there's lots of code and no one knows why. And this is always the ways in patterns. You can look at the Erich Gamma book, Gang of 4, is like you have a problem. Here's the solution. In Java 6, we don't have any problems. Right? And we had a problem 1945, right? Then the same solutions from back then we can apply again, and this is absolutely not maintainable. Gang of 4 patterns is also interesting. Factory, integral part of Java 6. It produces. Abstract factory, very similar. Singleton is at singleton annotations. You call it pattern, but it's integral part of Java E. Build a pattern, okay, build a pattern, you can create builders for domain objects. Interesting, prototype is actually request scoped. This is very like a prototype, and all these scope beans are like a prototype because they live once per scope. This is actually like a prototype implementation. Adapter pattern, you can do it. Bridge, CDI is perfect implementation of a bridge pattern. If you like, we can implement it in the workshop. What you can do, you can replace whole object hierarchies with one entry in beans XML. It's nothing else like a bridge pattern in Gang of 4. Decorator is even part of the CDI. Facade, we talk about this. Sorry, prototype. Flyweight, flyweight is the request scope implementation. What flyweight pattern does is there's only one instance per something. It was the sample in Erich Gamma book, like there is every character is only one instance of an A or C or D, because all the strings in Java are handled exactly the same way. And in CDI, all the objects, instances, are also cached, or not cached, are pulled. So there's only one instance per scope. Yeah? And prototype is actually similar to request scope, so it's just cloned. Yeah. Composite, there is nothing in CDI, but it's a more business-like pattern. But proxy, everything is a proxy in Java 6, with or without interface. Template, you can do it very, very nicely with CDI. Observer, integral part with add observes. Done. Visitor pattern is more like business. There is no equivalent of visitor, or something similar we have already. You can add inject instance, and then iterate over all implementation. It's like a visitor. You can very easily build visitors and chain of responsibility patterns. Command, it's easy, it's just one method. It gets a lot nicer with JDK 1.8 with single abstraction. We get lambdas, so it could implement it directly. Strategy pattern, you have to implement it if you need it. So it's actually anti-pattern in Java 6. Building everything interface is just to hoping that something, and one day something will change. It's not a great strategy. And chain of responsibility we had already. And state is a little bit harder to implement. It's a business logic. But what's interesting, 80% of Gang of 4 patterns are already built in. So you can just use an annotation singleton, you have a singleton. You don't have to write static fields and get instances and so forth. Build CI and Maven. Don't start with SuperPOM. This is like also crazy. Before they even start, they have a Maven POM, which is longer than a book, right? And if you look at this, it's just crazy stuff. It's just absolute anti-pattern. And I don't even use lifecycle hooks. So what I try to do is very fast and modular builds, and what I use Jenkins to chain everything together. So there is a great plugin called, actually multiple plugins, but Pipeline. Like you can visualize all the stages in the build. Jenkins is the job to build everything, not Maven. So Maven clean install executes, in my case, just unit tests, but this is crazy fast. Everything else, integration test, has to be executed from the IDE or command line. And in Java 6, there is the Maven build is about POM. It's 40 lines of code. I will create it at the beginning of the workshop. Nothing else. If it's longer, it's suspicious. And it is always longer in all Java 6 projects. It's just crazy what they are including there. It's just absolutely crazy. And if Maven doesn't work for you, it's probably time to switch to something else. So start with Maven. If you have to write your own plugins, whatever, probably Gradle is a better choice, or Ant or whatever. But Maven lives with convention over configuration. If you're not satisfied with the convention, do something else. Interesting, in Java 6, it works surprisingly well with Maven, because also convention over configuration, don't have to specify a lot. And by the way, all Java 6 projects are wars. I don't use ears anymore. There's no more obvious use cases for ears. And always start with CI, and as we already said, you have dedicated a person, a developer, or who does nothing else than improving the performance of Jenkins. It will always pay off. It's not like crazy. We have sometimes teams of 100 developers, and they're waiting for Jenkins to feedback. You know, they're burning thousands of euros just for that. Testing and stress. So unit tests and everything is very nice. I always got questions, what are you doing, test first or last or whatever. And I'm actually happy then someone is writing a good test. You know, there's not like everything is, we have 100% test coverage and we need for the next challenge. It's like usually there's nothing tested, or we have tests just for code coverage without asserts. Also very common, just writing tests like crazy to have Sonar or Jenkins satisfied, and no asserts because was no more time, right? It's no kidding. I have reviewed projects, so much, you know, test code and then assert not null or something, or assert true or false something, which doesn't even matter. So what I can tell you, everything which is more complex, I would say cyclomatic complexity higher than 3, it means if else else, it means 3 execution paths in a method. I would write unit tests for that, and I would never ever write a unit test for getters, setters, constructors, or toString methods. And the problem is then your code coverage would be not as high as someone whose own goal is to have as high as possible code coverage. So our goal is working software, not code coverage. Okay? And so unit tests, integration tests, and what we separate unit tests is unit tests, it tests just methods, everything is mock-out. Integration tests, you can fire up the database, whatever, but in unit tests not. Why? Fast feedback in unit tests. And stress testing, extremely important. At night, we have stress tests. And the stress tests are running the whole night because your application server will never, ever run single-threaded again. And no one tests that. This is just crazy, right? So everything is tested, unit tested. We have code coverage from 80% and never created a stress test to see how it actually behaves on a heavy load. So design for reuse, what I would like to say, there's actually no reuse, right, in the bigger companies. The bigger the companies, the less reuse you have. So you can attempt to make something reusable, but no one will reuse that. And what I see, and this is actually the problem, it's not a technical problem rather than political problem, because every department fights for its own, I don't know, glory. So if there is no strategy, there will be no SOA, no reuse. So what it also means, in my projects, there should be not 50 or 500 Maven modules. Like what the developers like to do is like to create its own module with interface, one class, in hope that another developer will reuse that. And if I observe myself, I will never do that, right? Who of us is scanning the repository and say, oh, this class I could probably reuse, just reuse it. Never happens, right? So if it never happens, just leave it. So we try to keep to reduce the amount of Maven modules to the minimum. In one current project, we have only 3 modules, but they started with 20. We deleted everything, and it works fine, right? So module means there is something reusable, really reusable. If reusable means you have from the beginning 2 clients for that. If there's only one, there's no reuse. And architecture essential is, what I just would like to mention is, start with the business and don't think in Java. So if you would like to build conference planner, we should have somewhere a package, planner, conference, talks, workshops. What I see in my projects, packages like beans, model, exceptions, common, infrastructure, utils. Like, who is building that, right? Who is paying for utils or for beans or for whoever, right? So you should watch, you look at their code and see the business, not the obvious Java stuff. So I think 10 a.m. So we are done. So thank you. Sorry for the management talk, but in the workshop we just code, no slide.